Hi, I'm Satyam Agrawala. Today I'm going to present features of my operating system and pipes, my term project. My operating system has a shell which supports the following commands. Most of these have been asked to implement in our assignments. The memory manager also looks similar to what was discussed in class. Every memory block has a header which has information about whether the memory block is free or used, about the PID and the size of the memory block. Devices in this operating system have two attributes. One is called major, other is minor. Major refers to the device type, minor refers to the specific device implementation. There are streams which are used to interact with devices. A stream contains information regarding the device like major number, the minor pointer, and the mode in which is going to access the device, that is read, write, or append, and a cursor location which is specific to in-memory files. Every device implements init, release, read, and write functions. All the streams in my operating system are stored in an array. The index of every stream corresponds to its file descriptor. This is an integer which is passed to the user, and he uses this number to perform all operations on his stream. My operating system also has some reserved streams for specific devices like UART in, UART out, push button in. The idea was to not have to create multiple streams for these devices and always use the same reserved stream internally. I also support the append mode for in-memory files only. Then I support multitasking in my operating system using the round-robin scheduler, and this is how my PCB looks. Notice I have an array of open streams in my PCB. This refers to all the streams opened by the process. The first three indices in this array are reserved for standard in, standard out, and standard error. And then there is an array of waiting PIDs. These are the processes which are waiting on this process to finish. This is the list of supported SV calls. All of this have been implemented in the assignments. My term project is about pipes. The idea is to let a process communicate to another process. How we can do it is for a process A, we can set its standard out as the pipe write stream, and for the process B, we can set its standard in as the pipe read stream. So whenever process A writes data to its standard out, and whenever process B reads data from its standard in, the data written in the pipe gets communicated from A to B. Now to implement it, I have defined pipe as a separate device. So for that, pipe has a fixed size character array and three parameters: NQ offset, DQ offset, character count, which makes sure that read and write to this array is done in a synchronized manner. And then there is a separate flag called end of pipe, which is set to 0 when the pipe is created and is set to 1 when one of the streams of the pipe is closed. To create a pipe, I have written a new function. It's called svc pipe, and after which the user will get two file descriptors. One will be the read pipe file descriptor and one will be the write pipe file descriptor. Internally in this function, I am just creating the pipe device and I am creating the read and write stream. The spawn function has been modified so that the user can specify a customized standard in, standard out, and standard error. Now read pipe. When I read pipe, I disable interrupts because the pipe array is accessed by multiple, in this case, two processes. If the pipe buffer is empty, I just keep looping until there is something in the buffer to read from. So every time I loop, I just kill the process. If in the meantime the end of pipe flag has been set, which means the other stream has been closed, I just set an error code, enable interrupt, and return. And if there is something to read, I just read it from the pipe array and then update DQ offset and character count. Write pipe similarly has disabled interrupts when we enter the function. If the end of pipe flag has been set, I enable interrupt and return. If the pipe buffer is full, I keep iterating until the pipe buffer has space to write to. And then when there is space to write to, I just write it in the array and update NQ offset and character count. Pipe gets deleted when both the pipe streams are closed automatically. When only one stream is closed, the end of pipe flag is set as discussed before, and any further attempt to read or write by the other process will return end of file. So now you're looking at the terminal window of my operating system. I'm going to start with memory map. Notice there are 19 blocks assigned to PID 0. These are the reserved streams I was referring to. And then there are two blocks to PID 1, which is the shell process. One is the PCB, the other is the stack. And there are two which are used for the memory map itself, for the string allocation. And the rest is free memory. Now I'm going to do get time and date. Sorry about that. Notice the time is fine. Now I'm going to do the multitask app. Notice the timer has started. If I press the push button, there is output on the serial device. And if I type data here, it goes to LCD. So now I'm going to close this command, which will end the serial to LCD process, but the timer and the push button to serial process are still running. So as we can see in the PS, there's 3 and 4. Now I'm going to show how I can block a process. I'm going to block the LED flashing. So notice the LED has stopped flashing, and then I'm going to wake it again, and notice it's flashing again. Now I'm going to show the list of files in my operating system. These are all just device files. I'm going to create a file using echo and output redirection. So this creates a file which has content. This has 4 words. So if I do ls, you can see F1 is there. If I do cat on F1, it says this has 4 words. Now I want to count the number of words in this file, but for which I'll use word count and pipe. Oops, sorry. So that shows there are 4 words in this file, which is right. Now I want to append F1, so I'm going to open it in append mode, and I'm going to add data to this file. So if I cat F1, notice that the new character has been added. And if I repeat the pipe command, notice that it says now there are 5 words in this file, which is correct. Now I want to show that I also support multiple pipes in the same command, for which I'm going to use a utility called print twice. So I'll create a new file. And I'm going to so this will print every character in file twice, including the new lines. So that's what we see. So that is all. Now I'm going to kill all the processes running in background. Notice now PS only has a shell process. And I'm going to delete the files which I created. Oh, okay, I need to close it. Notice those files are gone. And now I'm just going to see the memory map. Notice it's exactly the same as it was when I started the demo. And now I'm just going to see the time. Notice that's matching. So that's all. Thank you.